Okay, slope and rate of change. This is 4-4. Slope and rate of change, which are really the same thing. Now, you're going to need the slope formula for this lesson. You're going to use it over and over. This is a formula I would suggest you memorize. There's some things to know about the slope formula. To use it, you have to have two ordered pairs, two xy's. That's why we have a y1 and a y2 and an x1 and a y2 in the formula. This just means the first y and the second y. These are not exponents. The first x and the second x. Now, you really read it as x sub 1 and x sub 2 and y sub 1 and y sub 2. But most of us just shorten that to x1 and x2. That works beautifully. Okay, basically, the way you use this is you have two ordered pairs. And you go ahead and label them, because I've found that kids who label them get the answer right almost every time, unless they did some math wrong. Kids who don't label them mix the points up as they put them in the formula, and they usually miss it. So I label mine because I'll miss it without the labels. So I'm just going to take this one and go x sub 1, y sub 1, x sub 2, y sub 2. Done. Now I'm going to sub the numbers in the formula and find the slope. So first I'm going to say negative 1 minus, because that's y sub 2, and then y sub 1 is 2. Then I'm going to put in my x sub 2, which is 4, minus my x sub 1, which is 5. Then I'm going to do the math. Negative 1 minus 2 is negative 3. 4 minus 5 is negative 1. A negative divided by a negative is a positive. 3 divided by 1 is 3. So m equals 3. That is the slope of the line that goes through those 2 points. Now, something to know about slope. We don't really want a mixed number, so we don't want a decimal number either. So we either want a whole number if it comes out to 1 like this one did, or we want a fraction. It can be an improper fraction. We don't want a mixed number, we don't want a decimal number, we want a whole number or some type of fraction. Okay? Let's do another one. The instructions are always going to say, find the slope of the line that passes through these 2 points, or through the points. Find the slope. Well, first I need to label x1, y1, x2, y2. Then I need my formula. M equals y2 minus y1 over x2 minus x1. So, 6 minus 3 and 4 minus negative 2. Now notice 4 was x2, minus is part of the formula, and negative 2 was x1, so it's all got to be in there. 6 minus 3 is 3. 4 minus negative 2 is 6, because minus a negative is plus a positive. This fraction will reduce to 1/2. It's always a good idea to reduce, and the slope is 1/2. That's all there is to it. It's that easy. Now, here's something that can really help you while you're doing slope, okay? Anytime you actually have a graph, and you actually find the slope from that, which we'll do in a little while. We'll find the slope from graph. Anytime you do that, then you can tell whether the slope is positive or negative or horizontal, or 0 or undefined. So every time the line is slanted this way, any line that's slanted this way, any line that has that kind of a slant is a positive slope. Any line that's slanted this way has a negative slope. Horizontal lines, the slope is always 0, which makes sense. Like the ground would be horizontal. It's flat. It's 0. It doesn't have a slope. Vertical lines that are straight up and down, that doesn't really make sense with the concept of slope. So those are called undefined. So that helps you a little bit while you're learning this to know that positive slopes, negative slopes, horizontal, 0 slopes and undefined slopes always are certain lines. That's also found in your book on page 237 if you want to look that up. Now, finding slope from a graph is really super easy. First of all, when I look at this graph, my brain is already going, that's a negative slope. So I know my number is going to come out negative. So that's helpful. Okay? So what I do when I want to find slope on a graph is I find 2 points. Any 2 points that I know is not crossing, but any 2 points where 2 lines intersect. For instance, right here I know that there's a point because I put one. But even if I didn't put one there, if there wasn't one, I could find one where the 2 lines are hitting something exactly. So what I'm going to do is I'm going to start at the bottom point and I'm going to count up till I get to the top point. And then I'm going to go over either this way or this way to get to the other point. It's kind of like someone lives here, someone else lives here. You don't drive straight across houses and trees and fences. You drive up and over to get to their house. So that's what you're doing. But you need these 2 numbers. How far up, how far over, that is the slope. So when you go up here, you go 1, 2, 3, 4 up. So that's my top number. And then I go over 1, 2, 3, 4. So my bottom number is also 4, but that's a negative direction. Because I already know this is a negative line. It slopes negatively. So up 4 over negative 4, that gives me 4 over negative 4, which reduces to what? Negative 1. So the slope of this line is negative 1. Okay, let's try another one. Okay, here's my next line. Okay, I didn't put any points on this one because I want you to find the points. So let's look for 2 points where we know it's on the crisscross marks. Well, I see lots of points, but I think I'm going to go with the ones that are on the axis just because that'll make it easy. This one is definitely on crisscross. That one's definitely on a crisscross mark. So there's 2 points. Now start at the bottom point and count up. Okay, 1, 2, 3. That's my top number, and I'm going over 1, 2. That's my bottom number. This is a positive line. I went over in a positive direction. 3 over 2, that's the slope. I'm done with that one. Okay, let's look at the red line and the green line. Finding the slope of these is super easy because, look, the red line is a horizontal line. All horizontal lines have a slope of 0. So the red line, the slope is 0. The green line is a vertical line. All vertical lines have a slope of undefined. So the green line is undefined. Okay, rate of change is the exact same thing as slope. But when they want to do slope, in a word problem, sometimes they call it rate of change because they have actual things, real life things in word problems. But it's still slope, and you can still find it by using the formula m equals y2 minus y1 over x2 minus x1. See why it would be a good idea to memorize this formula? Now, look at these 2 real-life situations. These are 2 different situations. Situation 1, they did time and cost, and they ran the graph up and down. Well, in my brain, the minute I see that, I go, oh, time is x, cost is y, because that's just an input-output table. So here's an ordered pair. Here's an ordered pair. Here's an ordered pair. Could I take 2 of those ordered pairs, choose them, label them x1, y1, x2, y2, and fit them into this formula and find the slope? Of course I could, although the book is not going to say find the slope. It's going to say find the rate of change. Then, look at the second table. They ran it sideways. Anytime a table is sideways, the top thing is x, the bottom thing is y. So these are xy ordered pairs also. I could label those and put them in the formula and find the rate of change. It's just that simple. Here's your video homework. Find the slope. Find the slope. Find the slope. Use the formula. Have a nice day.